All right, so we're in section 8.7 today. It's something called function notation. Before I get started on the actual examples, I want to show you something to do with function notation. All right, does this look familiar to you? Y equals 3x plus 2?
Yes.
We know that that's function form. Well, function notation simply replaces your y value. It replaces your y value and puts in a function of a variable, okay? And we're looking at how the x value affects the f value, if you will, okay? So f of x is how we say it. F of x equals 3x plus 2. And really, there's several different ways I could say it. F of x, g of x, h of x. It's all just, different ways of saying function notation. Just like we're all students, right? We're all students, but we all have different names. Basically, that's what this is too. All right, just function notation. All right, so do you see the connection between function form and function notation?
Yes.
All you're doing is replacing y with f of x. So now in example 1, we're looking at substitutions. Now, with substitutions, I'm plugging in the value into the function notation to solve for some part of that function. Lots of function words, right? It seems like I just say that. Like, yeah, function, a lot of functions, okay? So we will be saying that word a lot. Doesn't necessarily have to be confusing. So in the first one, it says find f of x when x equals 5. So now I'm going to substitute in 5 for x. F of x equals negative 3 times 5 plus 8. All I did here was I took my value that it gave me and I plugged it back in to the function for x. And what is negative 3 times 5 plus 8? What is it? No. Negative 15 plus 8 is negative 7. And this is how you write your answer. F of x equals negative 7. But now look how the one beneath it is a little different. Now you're finding what?
X.
You're finding x now. And they give you a value of f of x equals negative 22. I want you to view f of x as one term. Even though it's two different variables, it's just one term, f of x. F of x. So I'm going to substitute that value for f of x. Go ahead and try to make that substitution. All right, so I make the substitution. Negative 22 equals negative 3x plus 8. Now I solve this like a regular two-step equation. What do I do first?
Subtract 8.
What do I do first, guys? Subtract 8 from both sides. Negative 30 equals negative 3x. Now what do I do? Divide both sides by negative 3, and x equals 10. X equals 10. So now I solve for x. It said, in the original, it said to find x, so that's what I did. I solved for x. Well, look at the third one. Find f of negative 4. So when we're finding f of negative 4, our initial thought is to plug in negative 4 right here into the first x, but that's not what we do. Because remember, this is one term. This is f of x. That's one term. We don't plug it in there. We plug it in here, always, okay? So find f of negative 4. I substitute negative 4 in for the x next to negative 3, and I solve. Go ahead and do that. Go ahead and solve. When we plug it in, what's negative 3 times negative 4? Positive 12 plus 8 is what? F of x equals 20. All right, substitutions and solve. Now I want you to go to your blank paper. Go to your blank paper. We're going to start this classwork assignment together. Instead of just giving you random classwork problems, we're going to do this classwork assignment mostly together today in class. I want you to turn in your books to page 428. We're going to start with number 1. Number 1. Okay, go ahead and do number 1 on your clean sheet of paper. So number 1, guys, it says write the equation y equals 4x minus 3 using function notation. So remember, guys, we are substituting y for what? What are we plugging in instead of y? F of x. So instead of y equals, it's f of x equals, and then I just copy it, 4x minus 3. Okay, you see that, Samantha? So I'm just substituting f of x for y to write it in function notation. That's it. Okay? Now, number 2, we haven't learned yet, so let's skip it. But look at number 3. All right, this is similar to what we just did. Find f of x when x equals negative 8. So substitute that into the equation that gives you in the directions. All right, and go ahead and solve. Try to do 3, 4, and 5. So on number 3, f of x equals negative 7 times negative 8 plus 4. Did you get negative 52? Okay, you should have.
Wait, I got negative 54.
All right, now, well, that's not right. Negative 56 plus 4 is negative 52. Number 4, you plug in the 3. 7 times 3 plus 4 gives you 25. Did you get 25?
Yep.
Okay, and then on the last one, you plug in 67 for f of x. Did you plug it in for f of x?
Yes.
It says find x when f of x is 67. You plug it in for f of x, solve to get 9. Who got 9? Who got 9? All right, so now let's move on to example 2.
Wait.
Nope, you got to just figure it out yourself. You should have it done, okay? So, but it is on the recording, so you can go back and watch it there. Now, in example 2, we are graphing a function. Here's the good news. It's in function form. You see it? But it suggests that we rewrite it using our x and our y. Okay, so pay attention to example 2. We're moving on. It's important that we rewrite it because this is a familiar format to us. All right, so Samantha, just like we were talking earlier, all we're doing here is we're replacing f of x for y. Okay, that's it. All right, so it's the same exact equation, and now, who wants to make a table? Anybody want to make a table? An XY table?
No.
Oh, what? That's not fun?
No.
What about substituting 0 to find your other intercepts? You want to do that? How about just look at the equation and graph it based on the information that's already there? So if I'm looking at this equation, we're on graph number 1 now. If I'm looking at this equation, where does my first point go? Where does my first point go? I can just look at it and know. Where does it go? I heard it. On the 1. Whatever my y-intercept is, this number, this last number in the equation, that's where my first point goes on my y-axis. So I come over here, and you already have at least one graphed, right?
Yes.
Or set up. And I plot my y value at 1. But how do I know where my second point goes? I use my slope. So go back over here to slope, guys. I use my slope 3/4. 3 over 4. What is it? Is it run over rise or rise over run? Rise over run. So I rise 3, run 4. All right, and then make sure on the graph that you label it in function form. Okay, so on your homework, your classwork, make sure that you have the equation labeled. All right, so now turn back in your books to numbers 6 and 8. You are allowed to omit number 7. Numbers 6 and 8, we are going to graph those two functions. Numbers 6 and 8. Guess what? There's nothing to show on your regular classwork. On that page, just write on number 6 and 8 on graph paper. Okay, on graph paper. And then on your graph paper, I want you to graph numbers 6 and 8, and then we'll go over it in just a minute. Okay, number 6. All right, what is your y-intercept on number 6?
3.
So everybody agrees that my point should be at 3 right there, right?
Yes.
Okay, Now I use my slope, but I start here at this point, okay? This is my starting point, and I follow my slope. Well, it says negative x. What does that mean my slope is?
-1.
Negative 1 over 1. My rise is negative, not my run. I go down 1 over 1 from that point. Okay? Down 1 over 1. Oh, thank you. Down 1 over 1 from that point. Plot my point, draw my line, draw my arrows, and I'm done. Okay, do you see that now, guys? All right, so you're going to have a couple more graphs like that. Well, look at number 8, though. Do you have a y-intercept? Do you have a y value? So what would that make it?
0.
0. So now you do plot a point at the point of origin, and then you follow your slope to find your second point in graph. All right, we've got to move to example 3 now because we're starting to run low on time. In example 3, nope, wrong thing. Wrong example 3. That's from yesterday. All right, in example 3 now, I'm writing a function. So now I don't even have the equation, do I? But I do have some information here that I can use to form ordered pairs. Okay? I can use this information to form ordered pairs, and I write it in the order that I read it. So g of 0 equals 9. I'm going to write 0, 9. See that? I just pull the values out of the function notation to make my ordered pair. Anybody want to take a stab at this one? G of 3 equals -6. What's going to be my ordered pair, Josiah?
3 and -6.
3 and -6. And now that I have two sets of ordered pairs, can I use my slope formula to find slope?
Yep.
All right, go ahead and do it. All right, so our slope, yes, is -5. So, but remember, I have to write this in function notation form because I had variables of g in here. I'm going to use g of x. G of x equals -5x plus 9. Wait, how did I come up with 9? How did I know positive 9? Because the ordered pair was 0, which I learned yesterday. The reason I knew g of x is because it gave me g values here in my original information. And remember, I'm writing this in function notation, not in function form, the y equals. So it's got to be g of x. All right, I want you to do at least one of these, okay? So turn in your classwork to number 9. Turn in your classwork to number 9. Pull out your ordered pairs, find your slope, and then write the linear function in function notation form.
You don't have to graph it, right?
All right, so what is my first ordered pair?
-4 and 12. -4 and 12. I got it.
-4 and 12. And what's my second order pair?
0 and 8.
0 and 8. And guys, the beauty of it is that one of the sets will always have 0 in it, so you can figure out your y-intercept. All right, so now you do your subtractions, and what did you find for your slope?
-4 and 4.
-4 over +4 because of the double negative. So -1 over 1. What's my y-intercept?
8.
8. So now I can write it. Wait, do I write f of x, g of x, h of x? What do I write? F of x, because that's what number 9 says. F values. F of x equals -1x plus 8. Technically, do I need the -1? Do I need the 1?
You just need -x.
You just need -x.
Yeah.
All right? Anybody get that right? -x plus 8? Good. Awesome. Hey guys, this is not easy. Okay? So you really may need to go home tonight and watch this video. All right, one more example. Okay, this one I really need you guys just quiet and listening. All right, because it's not that it's difficult, but it is kind of goofy to explain. All right, this is example 4. It's a hot air balloon example, I believe. Yes. Okay, so it's a hot air balloon example. Let's see, where does it start it? Yeah, the scientific balloon was launched near Antarctica. Okay, so it was a scientific hot air balloon. And we're trying to describe the balloon's altitude as a function of time. So the good news is that they really lay it out there pretty clearly for you what you're trying to find a function of time, specifically to do with the altitude. So that's why we use an altitude that is a function of time equals, but I need some type of value that is affected by the time. So how far does it rise per minute? Well, on page 428, it says it rises at a rate of 500 feet per minute. So I do A of t, an altitude of time, a function of time, equals 500 feet, and I multiply that by the same value of time. So now I need a value either for time or for the altitude. So a t, there's a t, okay? So it gives me a final altitude of 120,000 feet. Where do you think you're going to plug that in for? In for t or in for your altitude? Yes, of course. So 120,000 equals 500 t. Now how would I solve for t?
Divide 120,000 by 500.
Yeah. Okay. And it took 240 minutes, which is 4 hours, to get to an altitude of 120,000 feet. Not realistic, in my opinion. Maybe it is, but I mean, no person would be able to go that high, that's for sure. So it was a scientific balloon. They didn't say anybody was physically in it. All right, guys, this is like numbers 10 and 28 on your homework, classwork, whatever you want to call it. Okay, so if you understand that, that's everything you need to know for section 8.7.